When you study calculus, you're going to find that you encounter limits throughout. They're everywhere. So you need to, early on, as soon as possible, to make peace with them and understand them. And what I want to do now is help you to have an intuitive idea about what a limit is. This is not going to be a formal definition or anything, but it's going to help you to see how to evaluate limits by looking at the graph of a function. So as we go along, hopefully that'll become more clear what I'm talking about. But let's suppose that we have this function. Let's suppose that we have f of x equals, let's just say x plus 1. Something simple. Some very simple function, just a line. And let me make a quick sketch of this function. Okay, I'll just do a quick sketch here. It has a y-intercept of 1, and then it goes up, a slope of 1. So I guess it looks something like this, right? So now let's suppose I want to evaluate this function at various values. For example, I want to find f of 1. Well, of course, that would be 2, and you can see it here on the graph, right? I could say, well, what about f of 2? Well, that would be 3, of course. And then, of course, I could say, well, what about f of 3? Well, that would be 4, okay? And you can see it, 1, 2, 3, 4. Well, 1, 2, 3, 4, right there, yeah. So you can see the value at f of 3. Now, we could go a little above, and what I'm going to do is I'm going to focus right here on this when x equals 3. And this is how I want to talk about a limit. So you notice as we go below 3, and as x is getting closer and closer to 3 over here, our function value is getting closer and closer to 4. You can see that. Now, it would be the same thing if we went above it. For example, maybe we could have f of 4. Okay, f of 4 is going to be 5. We could say f of 5. Well, that would be 6, and you can see that here. So here's the thing. If we just think about what's going on here, and you might think, well, this is ridiculous what we're doing here, but what we're doing is we're going to look for a trend. In other words, as x is coming from the left over here, from the negative direction over here, getting closer and closer to 3, imagine that you're up here on this curve and you're directly above this x. And x is going here and you're connected to the curve. So you're being pulled along directly above the x. As the x is going to 3, where will you end up when x gets to 3? Well, you'll end right up here at 4. So here's what we say. We say the limit, we write it this way, the limit as x goes to 3 from the left. See, and I have a little arrow there, okay? The limit as x goes to 3, and I have a little negative sign up here like an exponent. The limit as x goes to 3 for this function is 4. Yeah. Now, we could do the same thing from the right. We could say, well, what happens as you're approaching from the right and you're up here on the curve? Well, we would say the limit as x goes to 3, once again, but this time from the positive side. And I put a little plus up there in the exponent position. So this would be like x plus 1, and we still get 4. So this is called the left-hand limit right here. This is the right-hand limit. Okay? As we approach 3 from the right, we get 4. As we approach 3 from the left, we get 4. Now, notice that that is exactly the same in this case as f of 3. See? So we would say this limit, and the function value are all the same. Now, here's the thing. If we write this, if we notice that the limit as x goes to 3 from the left is equal to the limit as x goes to 3 from the right, we say that the limit overall, we say, well, okay, the limit as x goes to 3 is 4. Because the left and the right are both in agreement, so we can talk about the limit overall. Really, we're saying as x gets closer and closer to 3, what is y getting closer and closer to? Well, in this case, 4. And you might think, well, that's just nonsense, because why do we talk about what it's getting close to? We could just plug in and see what it is, and that's how we know. But let's consider this function where it's not so straightforward. Let's suppose we've got some function g of x, and let's suppose that function is equal to x squared minus 2x minus 3 all over x minus 3. Now, let me, I'm going to do something here. I'm going to factor this. This factors into x plus 1, x plus 1, x minus 3, and of course the bottom is x minus 3. Okay, there we go. Now, notice that you've got an x minus 3 up here and an x minus 3 down here. And every value that we put in, for example, let's suppose we do g of 1. Well, g of 1 would be 1 plus 1, 1 minus 3 over 1 minus 3. Now, these 1 minus 3's will divide out and we just get 2. So notice, and we could do that for every single value, all the values that we obtained up here, f of 1, f of 2, f of 4, and f of 5, they would all be the same as g of 1, g of 2, g of 4, and g of 5. In other words, I could put in the exact same values that I put in up here for f, 1, 2, 4, and 5, and get the same values out. However, if I try to put in a g of 3, dig what happens here. We would get 3 plus 1 over 3 minus 3 over 3 minus 3. Now, this is unbearable. We can't divide by 0 this way. 3 is not in the domain of this function. The domain of this function is all x except x equals 3. So we can't just go and plug into this function and say, okay, and get a value out. So if you look at what this graph looks like then, this g of x, this graph looks just like f of x. It has an intercept here, and look, here's 1, 2, 3. Now, it has a slope of 1, but right here it has a circle. In other words, the graph is not defined there at x equals 3. So this function, this g of x, is defined every place except x equals 3. So we can't talk about g of 3, but what we can do is we can say, okay, well, what is the limit as x goes to 3? And I'll just put g of x. What is the limit? Well, so you can see now why we might want to have limits, because this function is not defined. However, we can talk about, well, what happens as we're approaching 3 from the left? What am I getting close to? Well, I'm getting closer and closer to 4 on the y, if I approach from the left or if I approach from the right. So we would say that this limit is 4. So we were able to talk about, well, what's going on around x equals 3 in terms of these limits. So we're looking at a graph here and we're saying, okay, how do I evaluate this limit from a graph? If I'm looking at this graph and I have 3 here and I want to know, okay, well, what is the limit as x goes to 3? Well, just stand here and think about going straight up until you hit the graph where you have graph to the right. Well, when you see that you have graph to the right, just take note of what your height is. And your height here is 4. See? You just get up here and look. I have graph to the right. What is my height? Well, you look over here and you notice it's 4. The same thing for the left-hand limit. You have the limit as x goes to 3 from the left. Okay? So you're going to be looking to your left. So you go straight up until you hit the graph, and you look over to your left, and you notice the height. Well, the height is 4. So you can see here what you have is you have a right-hand limit and you have a left-hand limit. And the overall limit, since those are in agreement, is 4. Okay, so let's look at an example of a graph that's a little more complex than the ones we just looked at. So here's a function, f of x. Let's pretend that this is the graph of f of x. Now, one of the things you notice here is you have some discontinuities here, right? You notice that there's a little jump here. You go from this level to this level. And over here, there's a little jump here. You go from this level up to this level, and then the function value there. Now, these open circles mean that that's, for example, here. The curve goes up, and it actually doesn't have a function value right here represented by this open circle. The function value is up here where you have the closed circle. So the open circle means, yeah, there's not a function value right there. In other words, right here where you have 1, 2, 3, 4, 5, 6, 7, 8, at f of 8, you don't look here for the function value. You look right here. You don't look where the open circle is. And that open circle is right above 8, so you have to look where you have the closed circle there. So, but anyway, let's suppose that we have this thing here, and we want to find some limits. Let's suppose that we want to find the limit as x goes to 1 of this function, f of x. So we come over here to 1, right here. And we're asked, well, what is the y value as you approach from the right and as you approach from the left? What does y approach? So you're standing here and you go straight up until you see graph to the right. And you ask, well, what is my height there? Well, the height is 1. You do the same thing as you approach from the left. You say, okay, I'm going to go up until I have graph to the left. See? And what is my height there? Well, 1. So this limit here is just 1. Now let's look at one that's a little more complicated than this. And notice we had the limit exist. The left-hand limit, the right-hand limit were the same. But let's go over here to 3. Let's talk about the limit as x goes to 3. Now, by the way, as far as the function value, f of 1, it does not exist, right? There's just an open circle there. The function actually doesn't exist there. However, the limit as x goes to 1, that exists. The limit exists. But now let's look at this over here. Now, so we want to talk about the limit as x goes to 3, but notice that's kind of confusing because you're saying, well, as you come from which direction, right? If you approach from the left, in other words, if you're standing here and you go up until you hit graph to the left, you're at this altitude. You're at this value for y. But if you go up until you hit graph to the right, you go up a little higher and you're at this altitude. See, this one. So this tells us that if we want to talk about this limit, well, it's f of x. Okay? If we want to talk about this limit, then we need to ask ourselves, what's going on to the left and what's going on to the right? So let's look at that. Let's talk about the limit as x goes to 3 from the left. Okay? The limit as x goes to 3 from the left. So here we are. We're at 3. Go up until you hit graph to the left, where you have graph to the left. And what is your altitude there? Well, 1, 2, 3. It looks like 3. And then we say, okay, well, let's try it from the right. The limit as x goes to 3 from the right. Okay, well, let's see here. We're right here. We go up. There's some graph, but it's not to the right. We keep going up until we have, see, think about your pencil. You move your pencil up until you can actually hit graph to the right. Well, I don't have any graph to the right of my pencil here, so I keep going. There it is. Now my pencil can pick it up from there and go. See, that's one way you can think of it. And it looks like that's going to be, let me see, 1, 2, 3, 4. So we got 4. Now, those are not the same. 3 and 4 are not the same, so we say the limit does not exist. Now, we could also talk about f of 3. Does that exist? Well, yeah, right here. That's where you have the little dark circle. So that indicates that that's the function value, so it looks like that's going to be 3. But the limit overall does not exist. Now, we can go to this next one over here, this one right here. So there's 1, 2, 3, 4, 5, 6, 7, 8. So we can talk about the limit as x goes to 8. Let's go from the right. Okay, the limit as x goes to 8 from the right. So I put my pencil right here at x equals 8, and I move straight up until I hit graph where I could then follow that graph down with my pencil. In other words, where I have graph to the right. So I go up, there's graph to the right. What is my altitude there? Well, it looks like my altitude is 3. So it looks like 3. Okay, so far so good. Now let's try the limit as x goes to 8 from the left. Okay. As we approach from the left, let's see what happens. So I put my pencil here, and I'm going to move it up until I hit graph where I can move my pencil to the left. In other words, where I have graph to the left. Not here. I have to keep going. Not here. Yeah, there's graph right there, but none to the left. So I keep going. There it is. Now my pencil could, follow that graph. But I do have graph to the left here. How high is that? Well, we just go over here. 1, 2, 3, 4. Looks like 5. Now, so the limit, the left-hand limit and the right-hand limit are not the same. So we say the limit overall does not exist. And I'll just put does not exist, D-N-E, okay? So that's how we can evaluate that. Now, we could talk about this. We could say, well, what is the function value? F of 8. Well, F of 8, we just come over here and we say, well, is there any place where I have a dark circle? Oh, there it is. And I guess that would be 4. 1, 2, 3, 4. Yeah, 4. So notice, we have the right-hand limit to be 3, the left-hand limit to be 5. That means the limit overall does not exist, and the function value is 4. So notice our left-hand limit, right-hand limit, and the function value were all different. Now over here, notice, right here, the function value, the left-hand limit, and the right-hand limit are all going to be the same, and the limit overall. So when you're looking at these graphs and you're wanting to evaluate the limit, you can know right away the limit is not going to exist if you see these jumps. See, notice we're at one level and we jump. At whatever value for x that is, whatever x, this is that limit, as x approaches that, is not going to exist. You'll have a left-hand limit, right-hand limit, left-hand limit, right-hand limit here, but no overall limit. So look for those jumps and beware of those.